Hello viewers, welcome to the session on polynomial regression in machine learning. Please make sure to watch all the prerequisite videos for your clear understanding and to make best use of it. Before moving ahead, let us understand what this polynomial regression means. It is nothing but a regression algorithm that models the relationship between a dependent and independent variable as nth degree polynomial. Here the key term is nth degree polynomial. That is, the original features are converted into polynomial features of required degree of order 2, 3 or n and then modeled using a linear model. This is going to be much clear when we are going to look into its formula. The formula of polynomial linear regression is much similar to linear regression. The only difference is in linear regression we were stopping at b0 plus b1 x1. Whereas in polynomial linear regression, we are extending our formula up to bn x1 power n. Let's look into its formula. Y is equal to b0 plus b1 x1 plus b2 x1 square plus b3 x1 cube up to bn x1 whole power n. Let us look at the algorithm of the polynomial regression. It is much similar to the algorithm of linear regression. So you may have a doubt what's the main difference between polynomial and linear regression. Let us understand it more clearly in the upcoming slides. When it comes to linear regression, we always try to put all our data points into this best fit line. Whereas in real world scenario, this is not possible every time. Let us understand this with an example. Consider the real world actual data are in the form of curvature. But our linear regression always try to fit this curvature into this linear fashion, which is not right. So, in order to overcome this, we have polynomial regression. Whereas, in polynomial linear regression, by increasing our degree, we can obtain a curvature line, means best fit line in the form of curve, thus overcoming the drawback of linear regression. Now, let's look at the pros and cons of the polynomial regression. When it comes to its advantages, it can work on any size of the data and it works best for non-linear problems. We have seen in our earlier slides that how we have obtained the best fit line in the form of curves. Whereas when it comes to disadvantages, one or two outliers in the data can seriously affect the result of the non-linear analysis, and hence we need to be careful about choosing the right polynomial degree for a good variance score. Before moving ahead with the practical implementation of the polynomial regression, let us discuss the general path flow which we have been following from the starting. Here the only difference comes at the step number 5, where we are going to implement our polynomial regression algorithm on the training dataset. Finally, your favorite section, now we are going to implement polynomial regression practically. I'm going to predict the salary of an employee based on his level. In this practical, we will analyze what's the difference between linear regression and polynomial regression. Okay, firstly, the process will be same. Since I am having only 10 records, I am not splitting my dataset into training and testing model. Instead, I am analyzing the linear and polynomial regression on the whole dataset. Okay, I have firstly imported all the important libraries and read the dataset into dataset object. Now I am going to split the dataset into independent and dependent variables. Okay, successfully executed. You can see all the levels are the independent variables and the salaries of the same employees your dependent variables. Now first I am implementing the linear regression. The detailed video is there for linear regression. I am just executing here. See, it has been successfully executed. And now let's understand what we are doing in polynomial regression. In order to use and implement polynomial regression, scikit-learn package provides a pre-processing module in which there is already a polynomial feature class. And here I am creating the object of polynomial features class and keeping the degree as 2. Now what you have to understand this major line firstly here. Here I am converting the independent values. Here I am converting the independent values of the dataset into the polynomial fit. Let me execute till here so that you can get clear idea. See, what I have done here is I am implementing the formula. We have seen in our formula that y is equal to b0 plus b1 x1 plus b2 x1 whole square. So what we are training here is we are just teaching our machine about the x1 and x1 whole squares. See, 1, 1, 2 square is 4, 3 square is 9, like that. And after that, I'm going to fit my data into the values. Okay. Polynomial regression is nothing but the extension of linear regression. So I'm creating the object of linear regression and I'm predicting the value by using polynomial feature into the linear regression. See, x poly, the one which we have converted, and we are predicting the y, and we are doing this in the linear regression. Let me execute this whole chunk of code. Okay, it has been successfully executed. Okay, when it comes to the prediction and plotting the graph, let's see first. I'm first plotting the graph for linear regression. See, as we have discussed in our earlier slides, linear regression always try to predict in the linear fashion, whereas our data set is in the form of curvature. So now I'm going to plot the scatter plot and prediction line of the polynomial regression. See, in comparison to the linear regression, this is more better than that one. Okay, now I'm going to predict for 6.5 level of the employee what will be his salary. I'm storing that in A using linear regression. Firstly, I'm doing it in linear regression. See, it has shown out to be 33,379. Whereas when we look into our actual data set 6 and 7, it has been overshoot because in 7th level we are paying 300,000, whereas here we are getting only 330,000 approximately. So it has been overshoot. But let us analyze what we get when we predict through polynomial regression. Before that, you need to understand this chunk of code. Here what we are doing is just converting this level into our polynomial formula into x1 square. What we have done there, we are fitting and transforming our independent variable of the polynomial regression, and then I am predicting. Okay, when I am predicting the polynomial regression, I am getting the value as 189,000, which is much in between of the real data set. 6.5 lies between 150 and 200,000. So I hope you are clear between linear regression and polynomial regression. Okay, as usual, I have included code snippets for your fast revision. You can take screenshot of it. I hope this video proved fruitful to you and hope you have gained something extra than what you were knowing earlier. Thank you.